Hello, my name is Runit Vashisht. I'm a solutions architect at AWS, specially focused on Microsoft technologies such as .NET and SQL Server on AWS. In this session, I'm going to talk about AWS Microservice Extractor for .NET. AWS Microservice Extractor for .NET simplifies the process of refactoring your application into independent services. It is an assistive tool that analyzes source code and runtime metrics to create a visual representation of your application and its dependencies. It combines data from code analysis and runtime profiling to create a graph that shows the metrics and dependencies for each component. This graph eliminates the need to manually correlate the outputs of various tools to perform code and runtime analysis. AWS Microservice Extractor for .NET identifies potential API endpoints to be extracted as independent services based on coupling between components, call counts, and more. After you group parts of your monolithic application into functionalities for extraction as separate services, you can use AWS Microservice Extractor for .NET to extract independent services that teams can work, develop, build, deploy, and operate independently. Let's take a look at the Microservice Extractor for .NET and see how it can be used to extract independent services from an existing ASP.NET MVC5-based monolithic application. To get started with Microservice Extractor for .NET, you can download it at no additional cost from aws.amazon.com. Once downloaded, you will see a home screen of Microservice Extractor for .NET, which will look something similar to this. Before you can start working with the application code, you have to set the microservice extractor up. For that, click on Settings and then click on Add It. The very first time you will see all of these options will be empty. Few things you have to select is, first of all, is the AWS region with which microservice extractor is going to communicate. The second thing is a name profile. This is the user identity which will be used to make calls to AWS APIs. If you're running it on a dev machine which does not have a profile, you will see this drop down empty. You can click on add a name profile, give profile a name, and you have to provide AWS access key ID and secret access key to create the profile. If you don't have access key, you can go to AWS Management Console, create an IAM user, and create the access key and secret access key for that user. In my case, I already had a user, so a name profile, so I'm going to select this from the dropdown. The next one is the working directory. This is the temporary location which will be used by a microservice extractor for .NET to store the copy of your source code and then work on that source code as you extract an independent service from an existing monolith. It is recommended that you keep the path of working directory to be short because when microservice extractor for .NET is working on source code in this directory, it is going to use MS-build to build the code. And there are some limitations. If the path of your working directory is really long, you can see some compilation issues as well. The next one, as I mentioned, microservice extractor is going to build your code at the runtime. And for that purpose, it is going to use MS-build. MS-build is one of the prerequisites to work with microservice extractor. If you're running microservice extractor on a computer which already has Visual Studio installed, it should have MS Build automatically detected and the path will be automatically populated for you. The next one is the usage data sharing option with AWS. This is selected by default. This helps AWS improve microservice extractor for .NET, but if you choose to opt out, you can uncheck the box and click on Update. With these settings in place, you are now ready to start working with Microservices Extractor for .NET. Click on Update and you'll be directed to the home page of the tool. On the home page, you'll see information about how Microservice Extractor works and how it will take you through multiple stages. In the stage one, it's going to help you scan your application code and then visualize different parts of application. And then it will let you group different parts of your application before you can extract those parts as independent services. To get started, click on the button at the top which says Get Started. You will be presented with a summary of all the steps once again. At the top, you can see stage number one or step number one is to onboard your application. Once onboarded, you can start visualizing parts of your application, and we will see in just a second how you can see different classes of your application and interrelationship between them depicted by a dependency graph. And then we will go ahead, group those classes and extract those classes as independent services. For this demo, I'm using a sample demo application which mimics an online uh, web store which looks something like this. This is an ASP.NET MVC5 application. And on this homepage of the application, you can see there is a list of products at the bottom and then list of properties on the left-hand side. Let's look at the source code of this application. Here's the application source code, and this application has a couple of controllers. These are the entry point or the front end of your application. These controllers are calling into different application services. For example, there is a home controller that we just saw, which is showing us list of products and categories. And the home controller is making call to various services. For example, inventory service to show the product information. Similarly, there is a order processing service and there is a shopping cart service as well. Now, this application uses entity framework, hence under the models, you will see some data entities as well as DB context as well created beforehand. Now, if my goal is to first visualize dependency between different parts of the application and then use that dependency to make a decision to extract part of the application as a separate service, can microservice extractor help me in doing that? Let's take a look at that. I'll go back to microservice extractor, and to begin extracting an independent service, I'm going to start with onboarding the application first. For that, I'm going to click on onboard application. I'm going to give this application a name, and in this case, I'm going to call it Gadgets Online. That's the name of the sample application. I can optionally provide some description as well, but for this demo, I'm just going to skip that step. The next step is to provide the path of my application's solution file or SLN file. And for that, I'm going to click on choose file option and navigate to the path where my application's source code is copied locally. Remember, microservice extractor is going to assess and scan your application source code to identify different paths or different classes of the application, and then to identify dependency between different classes. So that's step number one. Next step is, which is an optional step, is to provide runtime profiling data. Along with the graphical user interface, which is helping me visualize part of the application and then break part of an application as an independent service, microservice extractor also ships with a DLL, which can be used to profile your existing application. All you have to do is use that DLL, register the DLL, and update your IAS config file. And uh, on the runtime, the DLL will help collect some profiling data. And once the data is collected, that will help us in the next stage of visualization, where we will see different classes on a graph. And this data will help us identify how many times a particular class was getting called from another class. I have already collected some data beforehand, so let me go ahead and point to the profiling data, which I think is in profiling output. The next one, again, this is an optional setting. It is integration with Porting Assistant for .NET. Porting Assistant for .NET is another assistive tool which can help you analyze, assess, and estimate your .NET Framework applications and see how much of that application is compatible with .NET Core. Porting Assistant gives out a list of NuGet packages which are not compatible, as well as API calls which are not compatible with .NET Core. Along with that, you also get recommendations and suggestions about NuGet packages and about API calls which will be compatible with .NET Core or .NET 5. Now, Microservice Extractor can do that assessment for you along with doing the rest of the operations if you have Porting Assistant for .NET running on the same machine. In my case, I do have Porting Assistant running, so I do want to assist my application using Porting Assistant for .NET as well. Well, with these settings in place, I am now ready to start working with Microservice Extractor. So I'm going to click on onboard application. Now you can see at the top that my onboarding is currently going on, and I can see the same thing in the onboarding status as well. And right now, Microservice Extractor is creating a copy of my source code, dropping it into the working directory, compiling the code, and trying to identify all different classes in that application code and relationship between those classes. It will also use Coding Assistant to assess the code and find out compatibility with .NET Core. This can take a couple of minutes, so I'm going to pause the video and come back once onboarding is completed. All right, the onboarding process is completed now, and the status has changed from in progress to success. And now I'm ready to go to next step or next stage, which is to visualize parts of my application. To do that, I'm going to select the application from this list and click on Launch Visualization. Now, what you see on the screen here is the visual representation of different classes in my application. And if I zoom in, I can see the name of those classes as well. So in this dependency graph, each node depicts a particular class in my application code, and each edge between these nodes depicts the relationship or dependency between the classes. For example, I just selected the inventory node or inventory class, and I can see that this inventory class has three outgoing orange arrows. And orange arrows in this case denotes the outgoing or outbound dependency. So this inventory class depends on my migration configuration, and it depends on category class in my models namespace. Similarly, a couple of other classes. Similarly, these blue arrows denote an incoming dependency in my inventory class. You can see my inventory class currently is used by my home controller, store controller, as well as shopping cart controller. Another important thing to notice here is since we had the usage metrics, if I look at any of the edges between the classes, I also get a call count. For example, my inventory class was called the category class around 400 times during the data collection time. Similarly, inventory class got called from home controller once and from my shopping cart controller around 4 times while this data was collected. Now, there are a couple of other visualization options as well. You can click on explore alternate visualizations for grouping at the top, and that will show you your classes organized a little differently. I can cancel out from no details and zoom in. And now I can see that my classes are now organized um, as per the namespaces. All the services classes are in the services namespace. All the controllers are in the controller namespace. Of course, I'm going to get similar information if I select the same inventory class, which is part of my services namespace. Now, I can always switch back to the original view by clicking on back to main view. Um, By using this information, I can now start thinking about how am I going to create independent services from my existing application. For example, if my goal is to create an independent service using just the inventory class, which has dependency on a couple of entity framework entities, and there are a couple of controllers which depend on inventory class. All I have to do is select the class, right click on it, and add this class to a group. Remember, group is the unit of extraction. I'm eventually going to group one or more classes and then extract that group as independent service. Now, to add a class to the group, I can right click and click on add node to group. Since this is the first time I'm creating a group, I don't have any existing groups. So I'm going to click on create new and going to give it a name, inventory service. I can have more than one groups, and to visually differentiate between the groups, I can give any group color as well. Now, as soon as I select a group color, all the nodes in that group will be changed to that color. Like in this case, it's the green color. A few things to notice on the right hand side, I'm getting .NET Core portability information, and since this group has only one node, I'm getting an information that my inventory class is compatible with .NET Core, which is a good sign because it tells me that once my class new project will be created or once inventory is created as an independent service, I can potentially port it to .NET Core and then take benefit of maybe containerize it using Linux containers. Another thing is I also get a similar information in terms of dependency under the node summary. So you see the same orange and yellow arrows, which talks about dependency between the classes. In the general tab, I see some information about what is a class inside of this group and what are the other classes that this group depends on. Now, with this information, now I'm ready to extract the group. And one more thing before we start extracting, you can always add more classes to the group. In your real application, most likely you're going to have more than one classes. You can drag and drop nodes if you want to add a node to another group like this, or you can always drag it out or drag it and to drag it outside of the group to remove it from the group. But once you're ready, you can select the group and click on extract group, which will take you to the next screen where we will start extracting this class as an independent service. In the next step, I am prompted for some information about the service that is to be extracted. The first one is what do I want to name this service? So in my case, I'm just going to call it inventory service. I can optionally give description as well. It's going to take few seconds to perhaps a minute or so to make sure that the relationship between the nodes that are being extracted and the dependency between the node and the rest of the application is identified one last time before the extraction happens. Um, I'm going to pause the video while the metadata for the extraction is getting prepared up. And once this metadata is ready, we should be good to actually extract a microservice containing the inventory service. Okay, so the metadata collection is done, and now I can see the list of the nodes which are to be extracted, which in this case is my inventory class. And it has dependency on 20 other objects, which includes both the um, uh, custom classes which were part of the solution as well as system objects such as system.data.entitydbset and a lot more. With this list ready, now I'm ready to extract. One last thing is it is still possible for me to extract a microservice and still keep my invocations to be local in the existing monolithic service, or I can modify a copy of a monolithic service and change the invocations to remote invocations. And in that case, all the calls to inventory service, all the local calls to inventory services will be converted into remote REST API calls. With that setting in place, I'm ready to click on extract. Now the extraction process is going to take some time. You can see the status at the top. So it is going to do the analysis, do the compilation of the code, extract a microservice, which will be a completely different ASP.NET Web API project, and then a copy of monolith existing monolith application will be modified, and the local calls to inventory class will be converted into remote REST API calls to the inventory service. I'm going to pause the video and I'm going to let the extraction complete. And once it's done, I'm going to start recording again. Okay, my extraction just got completed and I can see the message at the top. Couple of things worth noticing. I would see that my extracted microservices now is available at this path. I can copy this path and open it in File Explorer, and I would see a new ASP.NET project. Let me just bring it over, and I can see that here's the extracted service, and in the inventory service, there is an ASP.NET project. I can double click open it in Visual Studio. Um, the same thing is if I go back to my microservice extractor, I can find there is a copy of my existing application, which is modified to start calling the extracted microservice, which is also available in the same folder. Let me open both the solutions and show you what are the changes that have been made. So post successful extraction, I could see that in the working directory, there are two folders created. One is for the extracted service. This is where the independent service or the microservice is created. And the other one is the modified copy of my existing application. Let's take a look at the extracted services source code first. So here is the extracted service, and you will notice inventory.cs is the class which I intended to extract as a microservice. So the whole class is copied as it is. All the dependencies, which is my entity framework, data model, as well as DB context, all those classes were also copied in the microservice code. In the controller, the functionality of inventory.cs class is exposed as an API controller. So that's why a new controller is created called as an API controller. One thing worth noting here is when a service is extracted, it's not 100% possible that your service is in the compilable state. It is possible that you might run into compilation issues. For example, when I did this extraction, the microservice extractor decided to bring along DB migrations, which may or may not be required. And there were some files which were attempted to be brought over, but those files did not exist, and hence I'm going to run into missing file exception if I try to compile this application. So you might have to do the refactoring post extraction just to make sure that your microservice can be extracted. Now let's look at the application code which has been modified. But before that, let's take a look at the original application code, how my inventory service was called, and then we'll look at the modified code. So here is my original MVC5 application. I'm in homecontroller.cs, and in homecontroller, I'm creating an instance of inventory class. And in the index section, I am creating a method called get bestsellers on on the instance of my inventory class object. Uh, After extraction, this code needs to be modified because in the modified application, rather than calling a local inventory class, I want to call remote APIs through HTTP REST endpoint. Let's take a look at the modified application code, the changes which AWS Microservices Extractor for .NET made. Here is the modified version of the code, the changes which AWS Microservice Extractor for .NET made in my existing application. So first thing you will see is rather than calling into the local inventory class, it is calling a method called getEndpointAdapter on the inventory endpoint factory. It's also worth noticing that while making these changes, there was an endpoint adapter that was added to my existing ASP.NET application. And this endpoint adapter has the endpoint adapter factory, which can either return a remote endpoint or a local endpoint. It's worth noticing that the local class is still retained, so I still have my local inventory.services. And if I want to use local calls in place of remote API calls, all I have to do is in my endpoint adapter, which was created by microservice extractor, there is web.config. I can modify that web.config and modifying the setting remote routing to microservices from true to false. And with that setting, all the calls from the endpoint factory will be routed to the local copy of inventory service. That's one thing. Another thing is microservice extractor is going to use best efforts to make these changes, but these are not foolproof. Depending upon how you were originally instantiating an object of inventory class, your code may look different, and it's possible that the microservice extractor may not be able to modify your code as well. And in those cases, you might need to do refactoring of your code and to make sure that in your code you are leveraging the endpoint factory to make remote REST API call. So that will be the refactoring part that developers may still have to do post-extraction phase. With that, we have come to the end of this demonstration. What we saw was a step-by-step walkthrough of using AWS Microservice Extractor for .NET. We started with onboarding the application where we pointed the microservice extractor for .NET to a sample ASP.NET MVC5 application. This application was analyzed and source code was scanned, And then in the next phase, a visual representation of the application was created where we could see the nodes and the relationship between those nodes, where the nodes were different classes and the relationship was the dependency between those classes. Then in the next stage, we selected one node, which in this example was an inventory class, created a group with the single node called as inventory service, and extracted that group as a separate microservice. And in the end, what we got was microservice, a separate ASP.NET Web API project, exposing my inventory class over the REST API using an API controller. And my existing application code was modified using an endpoint adapter. And wherever I was making the local calls to my inventory service, those calls were replaced by remote API calls using the endpoint factory. Thanks for watching this video. I hope you found the step-by-step tutorial useful. To get started, you can go to aws.amazon.com/microservice-extractor. Download the microservice extractor for .NET tool and try it with your application source code. Thank you.